Given that segment BD is a perpendicular bisector of AC, prove that angle DBA is congruent to DBC. So it appears that I'm trying to prove that this angle here and this angle here are congruent. In order to do that, I have to say that these two smaller triangles are congruent. Since B is a perpendicular bisector, it means that 1, BD and AC meet at a right angle. It also means that AD and DC have to be congruent because BD bisects it. The only other portion I need to mark in my picture would be this middle side that both triangles share. Let's see, these two triangles are going to be congruent by side angle side. Once we prove the triangle is congruent, then we can say that these two angles are congruent because of CPCPC. So we'll start with our givens. BD is a perpendicular bisector of AC, and that's given. I'll start with the perpendicular part. So since BD is perpendicular to AC, that means that the measure of angle ADB equals 90, and the measure of angle CDB equals 90. Because of the definition of perpendicular. Since they're both equal to 90, I'll set them equal to each other. And since they're equal, I will go ahead and say that these angles are congruent because our triangles are always dealing with congruence. My next step will deal with the bisecting part of my given. So since BD bisects AC, it means that segment AD has to be equal to segment BC. Since those two segments are equal, they also have to be congruent. And the last thing I need to say is my second congruent segment, which would be BD is congruent to itself. And that's the reflective property. The next step will be to say that the triangles are now congruent because I have two pairs of congruent sides and my congruent angles. So I will say triangle ADB is congruent to triangle CDB because of side angle side. And now that these two triangles are congruent, I can say that those angles DBA and angle DBC are congruent because of corresponding parts of congruent triangles are congruent. And there's my proof.